Hello, welcome back. Okay, we're moving on to question 9. Look, whenever I see a simple question like this, I start to get worried because it's never that simple, especially in the modeling problem solving part. Alright, but anyway, let's go on. The cross section of a channel is parabolic. It is 3 meters wide at the top and 2 meters deep. Find the depth of water to the nearest centimeter when the channel is half full. Okay, now I don't know, my English is not that great. I don't know what a channel is supposed to mean. So I suppose, we're talking about waters and half full, so I suppose something that carries water. Alright, so just when you come across a modeling problem solving question doesn't give you the diagram, which is most of the time, you have to draw the diagram yourself. Alright, so I like drawing. Let's, just like what Einstein said, imagination is far more important than this knowledge. Okay, so let's just show our Cartesian plane. Alright, so it says that it is 3 centimeters wide. So when I talk about waters, I know what parabola is. So when you talk about waters or holding waters, I would choose this one. Alright, this is the only way you can hold water parabolic. A water holding shape. So let's just choose that. So we go, okay, so it says it's 2 meters deep. So we go, it's -2, right? And then it is 3 meters wide at the top. So that means, let's just draw the shape first, like that. So since the total distance is 3 meters, that must be -1.5, and that must be 1.5, right? You divide it by 2, you get 1.5. So 1.5 from both sides, right? Okay, so we got a parabolic picture, graph looks like that. So now we have to figure out the actual equation for the parabola. So we know the general, the standard parabolic function is given by the form y equal to ax squared plus bx plus c. Right? Now the first one should be the easiest to work out, let's work out c first, because we got a coordinate here, right? This is a coordinate. So this coordinate has a 0 and -2, right? Your x and your y coordinate. So we can stuff it in here, right? So it'll be -2 equal to a0 squared plus b0 plus c. So our -2 will be our c. So that's easy. That's the first one. Okay. So the next bit we have to use is these two information. Alrighty-o. So this parabolic function has a root, which is the x-intercept at these 2 points. So the root is happening at 1.5 as x, and then 0, and it's also happening at 1.5 and it's 0. Alright, now let's just sub that in to the function. So that's what we get. So we don't get y anymore. So 0 equal to a -1.5 square plus b times -1.5 minus 2, because our c is -2. Alright, so that's the first one. So let's just solve that. So 1.5 -1.5 square give us 2.25. So it's negative, sorry, no, it's positive now. 2.25a minus, because it's a negative, it's 1.5b minus 2. So that's the first function. The second one, we'll use the second root. So 0 is equal to a positive 1.5 square plus b multiplied by positive 1.5 minus 2. So 0 is equal to, now that would be the same, 2.25a plus 1.5b minus 2. All right, so we've got two unknown and we've got two equation. We can solve it. So let's just there's solving simultaneous equation. You can use either substitution or elimination. Personally, I prefer substitution. I've always used substitution. I don't know why. It's just my method. All right, it's just my way. So, but for you, you have to find out which one you're more comfortable with. All right, so. Should I show you guys both of them? Yeah, let's just show you both of them. Okay, so if we use substitution first, substitution method. So we go, so we just choose one of the function. Let's just choose the red one. So 2.25a plus 1.5b minus 2. So let's move the negative 2 to the other side. Give us positive 2 equal 2.25a plus 1.5b. Right? And then let's say we want to find out the a first. I want to find an expression for the a. So it would be 2 minus 1.5b. So we just move it from the right hand side to the left hand side. 2.25a. And then divide everything by 2.25, and we've got an expression for a, right? So we sub a into the one of the previous equation. So sub a back into another equation. So which will be the blue one. So 0 equal to 2.25a minus 1.5b. 2.25a minus 1.5b minus 2. Now this one is where we substitute into here, right? So we substitute that into there. So it becomes 0 equal 2.25 multiplied by 2 minus 1.5b over 2.25, right? And so anything afterward is just the same. So it's minus 1.5b minus 2. All right. So now this 2 cancels out, right? So you will get 2 minus 1.5b minus 1.5b minus 2. So 0 is equal to so 2 minus 2 gives you 0. Minus 1.5 minus 1.5 just gives you 3. So it gives you negative 3. Right? So move the 3b to the other side. Positive 3b equal to 0. b equal to 0. Alright, so we've got the value of b. Alright. And then we just have to sub the value of b back into the function that we got a for. So sub b into a's expression. So remember our a's expression is this, right? So it's this one. So we got, let's draw it back down there. So we got 2 minus 1.5b over 2.25. 2 minus 1.5b over 2.25 equal a. Now we know the b is equal to 0. We're going to sub it into here. So 2 minus 1.5, 0 literally, over 2.25 equal to a. And that will give us 2 minus 0, because 1.5 times 0 is 0, so it's just 2 over 2.25 equals to a. So we can try that, 2 divided by 2.25. That will give us 8 over 9 equals to a. So therefore, the function is, at the end, the function is, so we've got our a, b, and c. So the function is y equal to 8 over 9 x squared. Remember b is 0, so we just ignore that, and then minus 2. Right? So that should be our original function. We can test it later on by drawing the function on decimals. So, but let's just work out the other method, which is the substitute method. Which is the elimination method. Most people like to use this one, but you know, I'm not the most people. I'm not the general. I'm special. All right. Okay, so to use the elimination method, right, the elimination method is, we list the two functions out. So we got 0 equal to 2.25a minus 1.5b minus 2. Let's just move the 2 to the other side. 2.25a minus 1.5. Oh, so there was a b there. So b. And the other function is the same. So let's just try to write that as well. Oh, we got it right there. It's 2 equal to 2.25a plus this 1.5b. Now this one is easy because we can already cancel out one of the variables or one of the unknown with just like that right now. So the process of elimination is aimed to eliminate one variable or unknown. So if we plus these two functions, all right, so 2 plus 2 give us, let's just draw a line there. 2 plus 2 give us 4. 2.25 plus 2.25 give us 4.5. And this bit which is gone, right? Negative 1.5b plus this 1.5b, then that's gone. And that is just 4 equals 4.5a. And 4 divided by 4.5 will give you a. And if you times bottom by 2, you get 8 over 9 equal to a, which is the same as before, right? And then all we have to do is just sub a into one of the equation to find b. All right, so let's just do it with the blue one. All right. Oh no, it's the red one. Let's do it with the red one since we're using red. So let's see the change back. 2 equal 2.25a plus 1.5b. 2 equal 2.25a plus 1.5b. Right? And then we just put it in. A over 9 plus 1.5b. Alright, so a over 9 times 2.25. I got a feeling we just give us something that we know. Yep, we give us 2 plus 1.5b. So when you move the 2 to the other side, you minus it. So 2 minus 2 is 0. 1.5b. And therefore, b equal to 0. So therefore, at the end, I should use a different color since I used the blue, red already there. I'll use back blue. So therefore, y equal to 8 over 9a. Sorry, x squared, not a. X squared. No b because no x because b is 0, and then the c is negative 2. Yep. So that's the same. All right. Let me just graph it on decimals to see if we get a shape, just as we just like what we draw here. Whoo, we're back. Okay, so I got the graph here. So it's just like what we draw before, what we predicted it would be. Yep. So the question says that find the depth of water to the nearest centimeter when the something popped out. So find the depth of water to the nearest centimeter when the channel is half full. All right. So look at the channel. Now, half full is I don't know how full is half full, but I can imagine half of this, right, being full. That would be half full, right? So first I want to find out how full is half full. Right, so we have to integrate the function or to find the area between the curve. Now be careful here, we've got two lines here. Now this is our, y equal to, that's that function there. But this function is another function is y equal to 0. And now you're trying to find the area between these two functions. Remember, it's always the top function minus the bottom function. So to integrate that, you need to go top minus bottom, which will be, the top will be 0 minus whatever that is, whatever the rest of the other equation is. So it will be 8 over 9x squared minus 2 dx. Alright, so we can just expand the brackets out. We expand the negative into the brackets, and it will be negative 8 over 9x squared plus 2 dx. Look, remember this point is very important here. You are always, when you're trying to figure it out, the area between these two graphs, this two graph is always the top minus the bottom. Right? Remember, it's always top minus the bottom. All right. So we can go back to integrating it. Okay. All right. So let's just pull the constant out first. It's negative 8 over 9 x cubed. Oh, sorry, no more integrate. So we haven't integrated yet. So this is x cubed, and we can separate them, like I always do. So that's a little dx over here, and this is a dx over here as well. So negative 8 over 9, and so this is still square, sorry, my bad. So it will get an integrate, it becomes a x to the power of 3 over 3, power raised by 1 divided by the new power, and we just multiply by these two. We're going to get back in there, and then plus 2x over here. Now, this is not a indefinite integral, so there's no c, because we're trying to find the area under the curve between these 2 points. So it will be 0 and negative 1.5. Rightio, so let's get them in there. So that would becomes negative 8x cubed all over 27. No. Wow, dear Lord. 39, yeah, 39 is 27. What's wrong with my timetable? Right, let me, I'm not very sure now. 39 is 27. 38 is 20, yeah, 39 is 27. Oh, whew, timetable. Plus 22x equal to 0, negative 1.5. All right, so we can sub those two values in. So it will be negative 8. 0 first, right, because it's on the top. Then minus the one on the bottom. So this is 2 times negative 1.5. Oops, 1.5. Alright, so the front bit will become 0, 0. Big 2, 0 here. Alright, minus. Now this method you just calculator, negative 8. So 1.5, or sorry, negative 1.5 cube will give us that negative 3.375 times negative 8 would give you negative 27, and negative 27 on 27 will give us negative 1 plus 2 times that is 2 times negative 1.5. I believe it would be negative 3. So you get negative 3 plus negative 1 plus negative 3. Oh no, so this is 1 because negative 8 times that would be give you 27. Yep, so it's 1. 1 plus negative 3 is negative 2. So it is 2 meter square. So we know that now this area when it's full is equal to 2 meter square. So when it's half full, it is like that, right? But like, look, we know water doesn't flow this way. Water will start from the middle, so from the bottom, and then, you know, fill its way up. And we are supposed to find where about of this is when it's half full. All right. Now, after we found the actual area occupied by half of after we found out the area that the water will occupy when the channel is half full, which is 2 meters square. Now we have to think about, okay, how is the water going to be, you know, leave in the channel? It's not going to be like that, right? Water is not going to go like that. We found it this way. We found the area this way, but we know that water doesn't lie in a container this way. So what water do is they will fill it up from the very bottom, and they keep going up, right? Just like that. So somewhere down there, there's actually a line, right? Somewhere down here, that the water inside there will be 2 meters square, and we are supposed to find out the depth, which is here. We want to find out what that is. Let's just call that the depth. And we're trying to find out what that is. What's the depth? That's what the question asks us, right? So say find the depth of water to the nearest centimeter when the channel is half full. So we know when it's half full is 2 meters square. And then the depth is right here. No. Alright, let's just treat it this way. This is an interesting question. It takes a bit more than just normal understanding of integral to solve it. You just have to see the picture yourself. Look, we are literally looking for the area between this function and this function, right? So great, let's write our integral first. So the integral is between okay, I'll go back with the blue pen. Alright, so the integral is top minus bottom. Alright, it's always top minus bottom. Alright, so we got this bit is the top function. This bit is the bottom function. Now the bottom function is easy. The bottom function is the function that we've been given. We found out previously, which is this. This is the bottom function. Right, 8 over 9 x squared minus 2. So just write it down somewhere. Oops, stop popping up. So this minus 8 over 9 x squared minus 2. So this is the bottom one. Now the top one. This is the tricky part. Okay, how do you find the function of the top one? Well, we know that the top one is the depth, right? So the depth is equal to a certain y value. Can you see? It's a certain y value on the graph. So this particular certain y value on the graphs. So this is equal to y. Right? So it is a y value. So it's equal to a particular y value. We don't know what, but it's a y value. And it's also equal to the bottom to our parabolic function at these 2 points. Right? Okay, we don't know what that point is. But let's just treat the distance between let me use a red pen here. So let me just treat the distance between the two as k. Alright, so as k. And since our function, the parabolic function, is given by 8 over 9 x squared minus 2. Now, instead of x squared, we don't know, we know this is an x coordinate somewhere. We know this is this represents an x coordinate, and the k also represents an x coordinate. As you can see, k is a horizontal displacement. So instead of putting a x in here, we put k here and square it, because that's where x is. We're just substituting x into k. Sorry, we're substituting k into x. That's all. So we get that function. The depth is equal to y and is also equal to a over 9 bracket k squared minus 2. So since we got that, we can put this one. We can put this one into the top, right? Because that's the same thing. So we get 8 over 9 k squared minus 2. Right? Good. And now, and then the one will say, well, where do we integrate it to? Remember, we integrated, the distance we are trying to integrate is from 0 to k. Right? If that is k, then it's from 0 to k. That's how far we're integrating. Now notice that I didn't go from negative k to k, because I know the distance, the area will be the same. If you go from 0 to k, you literally get half of your area, right? So we know the total area here is 2 meters square of water. So half of that would be 1 meter square of water, right? So we can just go k over here and 0 here and put a 2 in front of it. And that the whole thing would give us 2 meters square, because that itself is just 1/2 of it, and we multiply by 2 because it's symmetric. It's exactly the same, because the depth is just a straight line. So that's why we can just multiply by 2 and get the full area. So, but before we do anything, if you can move the 2 to that side, and that just become 1. You can divide it by 2 by both sides. So that makes things easier. All right, let's expand the brackets. So it's still k, still 0 here. So it's the 8 over 9 k squared minus 2. Now let's expand the minus into both of them. So it will be negative 8 over 9 x squared plus 2. And then integrate with respect to x. I should put that on there as well. Okie dokie. So now the 2 will cancel out, right? So you literally left with k0, 8 over 9 k squared minus x over 9 x squared, right? Okay, and then we go integrate with respect to x equal to 1. Okay, and then let's just integrate. Now, remember, when you integrate the first bit, none of them is x's. So this itself is just a constant. It's just a number, all right? Just a number. So when you integrate a constant with respect to a variable, you just get the constant multiplied by the variable. Yeah? Remember, k is not x. We are integrating with respect to x. There's no x in there. All right? And then we go, now this is the one that you increase the power and divide it by the new power. So divided by 9 times 3. And that gives you the area. So we go 8 over 9 k squared x minus x cubed over 27. Right. So literally we have what comes after is we have to do the definite integral. All right. So so k. So first we sub in where k into wherever x is, right? So that minus and then we substitute 0 into wherever x is. Now we know everything in here just becomes zeros. Alright, so I'm not going to write that down. So what the thing interesting here is here. A over 9. This is k cubed now. Minus 8 over k cubed. Oh, my k should be the same. Over 27 equals to 1. Now I'll have to multiply this to get to the common factor. Multiply both top and bottom by 3 to get to this common denominator. So it would be 24 over 27 k cubed minus ak cubed over 27. And then I multiply 27 on both sides. That puts 24 k cubed minus ak cubed. Both sides, I mean that side and that side. The left hand side and the right hand side. Yep. And now we go so 24 minus 8, 16. K cubed equal to 27. And k cubed is equal to 27 divided by 16. And then k is equal to the cube root of 27 divided by 16. Right, so we've got our k, right? Which is, look carefully, which is our x here. This is our k, right? So we got that, and remember, once we got the k, we can sub the k value back into the function to find the depth, to find our y. All right. So we know the depth is equal to y is equal to 8 over 9 k squared minus 2, and we just sub the value into here. Is equal to, so depth is equal to 8 over 9 3 root cube root 26 and 7 on 3 square minus 2. And let's punch it into the calculator to see what sort of result we get. So let's go cube root 27 on 16, we get something, and then we square that, we get something, and times it by 8 over 9, we get this 1.2599, right? We've got 1.2599, yep, minus 2. And so it would be negative 0.74. Right, so this is our depth. Centimeters. All right, so if we go back to the graph, so we go, so this is negative 0.74, so we go from 0 down to 7.4. So let's just say this distance here is so let me rub it off here. So this point here right now has a coordinate of negative 0.74 as the y coordinate, and the k is, remember, is cube root 27 over 16. Right? Positive, negative. Oh, on that case, yeah, positive, negative, because you got both sides. All right, so that's our depth. But if you go from bottom up, bottom goes up, then the depth would be 1.2599, which is, if we round it up to 1.26 meter, or is equal to 126 centimeter. All right, that's the answer. Or you can, so let's go. Therefore, the depth of water is 126 centimeter from the bottom to the top. So count that way, or negative 0.74. So that would be, let's convert that to centimeter. So this is meter, is also equal to roughly negative 74 centimeter, or negative 74 centimeter from top to the bottom. So give a direction like that. So that's our answer. All right, so this bit, look, this bit is the crucial bit that you guys have to be able to see. Treat this as a K and find the function for the depth of the line, the depth of the water as a function of y, and is equal to, you know, just coming up with this is the hardest bit. Remember, this is the bit that you have to get your head around. And other than that, you know, things are easy. Okay. Now this is, even though, like I said, I hate it when you see a simple question like that, because it's never that simple, and it, you know, it shows out it is never that simple. It is, you know, it involves you to think about it and, you know, picture it and able to imagine what will happen. So yeah, definitely, I think this is a standard question, definitely. So I'm glad that I can help you to finish this and show you how this has been done. So whenever you come across some similar question in the exam, you know, you will be able to at least work out the answer. I wouldn't say ace it, but at least work out the answers. All right. Okay. After all this talk, I'm tired. All right. Let's head into a commercial break, and we'll come back with question 10.